Welcome to Offsite Builder. We're joined today by HolzRaum System. And in our world, we're used to BIM and we're used to a large array of manufacturers, right? And each one has their unique system. So taking it one step further, we can look at a single integrated manufacturing model known as SIMM. I would like to introduce you to Ilka Cassidy and Steve Hessler. Welcome, guys.
Thanks. Hey, Mark.
Thank you. Thanks for having us.
So you prepared a presentation of SIMM. I am in love with what you guys do. It's every layer of what you pull together is a way of connecting both the designer, the developer, owners, right, of projects and sites, and then the huge amount of different manufacturers out there. I think that is one of the reasons I get so excited to sit down in front of the computer and run through projects with you guys. So how about you take us on a presentation, introduce your team, and let's get into some conversations.
Sure.
Sounds good.
Yeah. So yeah, thanks for having us today. And we're definitely happy to talk about our SIMM process. We put a lot of thought into it, and we're always trying to explain it as simple as possible. We're actually going to use this project as an example of kind of walking you through, our process and how it all works. And then at the end, Steve is actually going to show you the live model of this. So talking about our team, this is us. We are 3 co-founders of HolzRaum System, and we always think it's important to introduce ourselves because it makes it a little bit more easy to understand of why we're doing what we're doing, because it's definitely looking at a lot of different perspectives, and that is because we're coming from a lot of different backgrounds. So I am an architect. I was trained in Germany, and I'm also a certified passive house consultant, and I really like to do energy modeling. And then there's David Hessler. He is actually a biologist and a software developer. And then Steve Hessler, he is a passive house builder, a certified passive house consultant, and he is also a timber frame and structural designer with a background in CNC production of building components. So there's quite a bit of different things that we always think about and talk about. So Steve and we actually met, I think, around 2015 at the first Passive House gathering in Philadelphia. So Philadelphia by now is a pretty active Passive House community, but back then there's nothing really there. So it was really, really nice to finally connect to other like-minded people in terms of Passive House. And Steve and I connected pretty quickly because Steve was working for a passive house builder at that point, and I was starting to design passive houses. So we connected on a couple of projects, and we really got interested more and more into the offsite manufacturing because we've always felt like that is a key to scaling up high performance homes, and passive house construction make it more available to a broader audience, basically make it more possible for builders to build passive houses, and make it easy to look at air sealing for people that haven't really put the time and effort into learning all of this. So we decided to specialize on not only on performance-based carbon, lowering our carbon footprint that way, but also on embodied carbon. So we only build houses that only use natural materials where we can. Of course, sometimes we need to go back to some kind of foam-based assemblies, but typically in our panels, we use wood fiber insulation, cellulose, hemp, so everything that has a very, very low or negative carbon footprint. So, and then once we started actually working with offsite manufacturers, we realized how much of coordination and communication has to happen between the architect, the builder, and the manufacturer. And we saw kind of a lack of that happening. So it was a little hard for us to really engage with the manufacturer. And so we realized that there's quite a bit of potential in you know, this kind of area where, you know, someone's basically needed to mitigate there and become that communication piece. So this is, I guess, we typically start out saying that we are not a manufacturer, because a lot of times people actually believe that we are manufacturers, but we are actually independent. So we work with several different manufacturers. And what that did is that we actually had to really figure out a communication piece that is more universal, because we have to communicate with several different manufacturers in terms of what the outputs are, you know, what they need from us, but also, you know, we had to figure out how to get everyone at the same table and being able to talk about the same thing and not leave anything up to, you know, anyone guessing anything. So we came up with a tool that we call the Single Integrated Manufacturing Model, the SIMM. And what's really interesting is that we can start out engaging with everyone who is part of the project: the builder, the architect, the homeowner, the engineers. And we can start creating this, we call it this model, a visual database, basically. So we can start very early on communicating that way. And what the key to this is really that this one model gets actually developed all the way through production, so that at the end, this single model that looks at all the different perspectives with input from everyone actually gets developed into something that you know, becomes a panel drawing at the end and gets produced by the manufacturer. So this is the project that we're talking about. This is a very large single family home in Big Sky, Montana by Reed Smith Architect. And this is actually hybrid between a CLT floor and roof system and light framed panels. So this is a pretty, you know, intense and complicated project, and we didn't want to show it to scare people away, but just to show what's possible with this kind of approach. So to kind of highlight what a SIMM is, we need to kind of show and explain what a BIM is first, right? So what we get a lot of times is a BIM model or a volumetric model from architects. So volumetric models are really, really good at conveying design intent, and you know, for the architect to communicate in in kind of conveying construction strategies and explaining spatial relationships between assemblies and building components. And the outputs for a BIM model, or in this case a Revit model, are, you know, what we kind of know: floor plans, elevations, sections. This is very good at architectural documentation and is absolutely needed in the design process. It's really good at showing, your elevations, your heights, your schedules, window schedules, finishes schedules, and all of this. So then this, on the other hand, is a parts-based model, and that's what it looks like. So you can see the difference. We moved something that was a volumetric model into a something that shows every single piece that it's that building is built with. So this is basically then the outputs of a SIMM model, which is very different from the outputs that we saw before, because this is, for example, a 2D geometry review set, and it includes installation drawings and panel shop drawings, and it can also conclude in some cases in machine files, right? So, and again, if the decision was made to off-site manufacture a panel, then the design intent must get translated into actual parts, and a 3D parts-based model is necessary. So that's kind of a really important step here, that once you make that decision to go with pre-manufacturing, you need a parts-based model. There's no way around it, really. I think with modular building, it's slightly different, but if you go with panelized, you just have to do it. So, and that's kind of where we saw our opportunity, because once you have this this parts-based model that has to be built for everything that the manufacturer is going to produce, there's quite a bit of more opportunities that can be taken advantage of. And then this is just kind of showing what the manufacturer, if it wasn't our SIMM modeling approach, what the manufacturer would actually produce, and which is basically what they are going to build. So this is a model that would come from a manufacturer. So these are exterior walls. In this case, it's CLT floor panels, roof panels. And once we have all these basically production fidelity building components modeled, we saw quite a bit of opportunity, or big opportunities, to align and clash detect these parts against all of the other building perspectives. So that's kind of where the SIMM comes in, where all of a sudden, because we have already this model, we can start looking at the load path, for example. And this model was provided by the structural engineer. So we actually didn't we had to tweak it, but we try to use everything that we can get from engineers and to integrate that into our model. So we don't always model everything ourselves. We're trying to reduce redundancy. And then we were able to check this against foundation drawings and actually generate the model that works with the foundation drawings. And then we are able to feed that back out to the on-site construction manager to check dimensions. Then we are integrating the whole MEP model. Again, this was not built by us. This was given to us. This is a Revit model that we were able to integrate into our SIMM. And then we go ahead and really look at all these different perspectives against each other. The load path, the foundation work, the interior walls, the floor panels, the roof panels, accurate window and door units and their placement. And that was again defined by the architect's Revit model. So that definitely has a lot of value in terms of geometry and where things are. And then this is basically looking at a holistic model at the end, and Steve will show a little bit more of what that model actually looks like. And then to take it a step further in this project, we were able to actually integrate a terrain model, or we were asked to integrate a terrain model, which was provided by the excavation contractor. And then again, we checked it against the concrete. So then overall, we always, all of our details are developed with focus on airtight transitions and thermal bridge free connections. So I think that's kind of where my perspective then comes in a lot of times with energy modeling and, you know, being the air sealing, I don't know, person, guru.
Boss.
Yeah. And this slide always makes us really happy because of that little picture on the lower right, where one of the opportunities we saw in our SIM model is that it can actually be used then once construction started on site, right, by the contractor. And he's sitting here in his trailer looking at our SIM model and using that as a communication tool with his subcontractors.
He's still using it 6 months later. He's using it to like locate nailing for some specific siding facades.
Yeah. So yeah, again, you know, further down the road, it's a communication tool. You can turn it, you can twist it, and everyone looks at the same thing at the same time, right? And so this is what communication looks like in the SIM world, and it can look a little messy, right? But you can see that there's a lot of people looking at it at the same time. And yeah, we can make decisions on screen very quickly with everyone engaged, but we did see that we needed some way of coordinating or organizing that chaos a little bit. So we actually went ahead, and that's where David, our third party, came in as a software developer, where we developed the SIM model basically as a visual database. And this is our software that's called Catch, which is basically harvesting information out of our visual database in a format that, you know, users can then use however they see fit. And also integral into this process is, you know, it's kind of the part of herding cats, because we're dealing with a lot of people. So part of this software is an issue tracker and data storage and a few other things that we're happy to talk about later on as well. And key to that is, and I'm sure Steve is going to show that a little bit more, is data attachment. So every little piece, and that's something that's a little different too, again, compared to a BIM model where, yes, you have layers, your walls, you know, you can set up all these layers and there is data, but it's basically one wall, right? And for us, it's every little piece that we create, if it's a screw, if it's a beam, if it's a post, can get data attached to it pretty much unlimited. And that data then is, you know, we're able to catch it or harvest it in a way that, you know, makes sense to everyone engaged. And then I guess coming back to the end, what's important again is that this whole process leads to these drawings at the end, or machine files. So there's no disconnect between a drawing and something that gets built. There's basically, this is the model, everyone is engaged, it's a digital twin, so to call it. And then out of that model, we basically export these 2D drawings for, you know, contractors that might want to build them in their shop, or have maybe a half automated production line. And we see a lot of potential in really engaging, you know, broadly builders locally that want to build those panels, so that we can really scale this up. And then alternatively, we can also, out of the same SIM model, export machine files for highly automated manufacturing facilities. So yeah, that's basically our process. And yeah.
Okay, it's incredible because every process you take us through are it's inclusive, right? It's receiving all the information from the various experts at hand. It's compiling it, and you used a phrase to make sure that how the structural and mechanical didn't interfere with one another. Used a unique phrase for that, clash detection.
Mhm.
Incredible, and all those layers coming up with it. And a catch, when you brought me into catch, I was like, all these tools are ready for now bringing all the answers that are needed and the files needed for panelized facility over here, CLT facility over here, and a stream of manufacturer parts and pieces here, there, and everywhere. It's a wonder buildings get built without this. I'm mesmerized. Steve, I know you got a lot to add, but Ilka, this is tremendous, and you have the mic, my friend.
All right, awesome. Thank you, Ilka. That was a great overview. This is actually the complete model, and you know what's actually kind of fun about this is that this is actually the version that we sent to Builder. So even though it all comes from one model, we can kind of tune some versions of it because different audiences have different purposes, but the content is always from a final frozen production model. So we actually just got to the part with this project about 3 or 4 weeks ago where we finally absolutely froze, and Collective Carpentry are fabricating the wall panels, so they have all of their wall panel drawings. So all the production numbers for all the parts are frozen. And when we get to that point, then we can release a version for the builder. So the builder actually has this model. I'll break it down a little bit, but they can grab, and they have CAD work, so they can actually open up this model. They can't edit it, but they can grab a lot of the things I'm going to show you. So we organize the model, you know, when we bring the design and the design content from others, like from our collaborators, when it comes in, it sort of comes in from all different kinds of sources. So it could be from Revit models from 4 or 5 different people, could be 2D CAD, it could be just about in every format. And our job is to bring it in, filter out what's useful, and not necessarily discard the other stuff, but to sort of put it out of the way, right? It's like we kind of put it on the shelf. And one of the ways we do that is we organize the building from the very beginning into like what we call slices. They're scope slices. So for instance, and so right now, all these scene tabs down here, these are just some of the scope slices and perspectives. We can do it on many, many different levels. But for instance, I'll just real quickly show you. So this is sort of the building. And then, you know, we can look at the foundation. These are some of the load path members. So these are all this local steel. And the blue is glulam parts, US glulam. There's also, I can jump over to, this is the imported CLT and some glulam parts. So I'm going to show you how we can start to put these things together. But the point is, we break these things into these individual slices, and that's one way to navigate the content very quickly. That's the thing we also really love about a SIMM model versus a BIM model, is that we can navigate parts like light speed, whereas it's not so. First of all, a lot of the parts aren't in a BIM model, but even if they were, you're limited a little bit by layers, which is still, layers are great, but there's sort of always so many layers in a BIM model. And what's great about this is that if I, like, for instance, I'm going to go look at the lumber. So this is all the lumber that is in the project. It's not the CLT, but it's all the spruce pine fir, it's LVL, it's plywood. It's things that you could get from a lumber supplier. And what's great is if I click on one part and then I look at all the properties, there is a lot of data attached. You can see there's a lot of blank attribute layers, but there's a lot of layers that are attached, and there's sort of unlimited number of layers that could get attached. This, just from this screen, I know what the part number is, but I also know like what panel it goes in. I know if it's field applied or factory applied. So basically there's unlimited data that you can attach to a part. And what's so cool is as soon as you attach data to a part, every single one of those like attribute layers is a navigation tool in the SIMM. So for instance, if I have this part active and now I have everything back on screen, but I'm interested maybe in looking at all the parts that share the material. So I can activate along material type. And now I had 20,000 parts on the screen a second ago, and now I'm looking at just those parts. So if I wanted to look at all the glue lamp parts, because I activated along the same material, but I'm interested in maybe what that looks like against the steel, now I can bring in the steel. And if I want to now say, well, let's see what that stuff looks like next to the MEP. And let's just do a quick look, maybe we're having a Zoom and bring the MEP engineer in and we're saying, you got to clash somewhere, right? So basically, because it's actually like the data, the more data, the better. It actually creates all these little opportunities to navigate and kind of filter out and in content. So if I'm going back to some of these scene tabs on the bottom, now we're looking at the lower level. So this is the lower level of the floor. I'm going to leave the MEP in on a couple of these, but you can imagine how useful this is when we're in our meetings. And, we're talking about literally every interior wall framing has been clash detected and created clearances for MEP and everything else. Main level, there was a lot of work with the CLT. That's a model of Mark right there. Yeah, I'm going to show you more on the CLT in a second. And
also seeing, Steve, I'm also seeing an option to understand what the critical path is and the sequencing, because often when we have these pre-made partitions and the glue lamp coming in, you have those different layers, and it is giving people the foreshadowing of knowing what crew is coming up and what to be expected for, because we don't have that in a 24 by 36 black and white piece of paper.
No, that's a great point. And actually, so if I take this part, then I know that part ends up in wall U10. And if I go look at the sequence, there are 17 sequences in the building. And so this right here, it says part installation sequence. This is sequence number 12, upper level wall panels. So I can do that for 20,000 parts in the model. And if I want to, actually, this is kind of nice. I can say, activate along a sequence. Go to these are some custom HolzRaum sequences. I go to 50, installation sequence, see all our sequences. So now I could say, I want to see everything in load path wood on 7. Now it should be all active.
Wow.
And now I'm looking at load path members for sequence 7. And then I can say, okay, how does that look on top of the CLT? So I'm going to go back to Hauslocker. And now I'm looking at what that would look like on top of the first floor CLT installation. And then, it's just cool because it's not just, you can just mix and match between those attribute layers. That's what I love. So we've been looking at sequence, then we moved to scope. Now we're going to move to SPF. So I want to look at, I'm like, okay, what does the SPF look like? Well, now I'm looking at all the SPF. So you can just jump around between those perspectives, right? Every one of those attribute layers, whether it's material, sequence, slice scope, vendor, like all of those things, they all become a perspective, and you don't have to be just looking at like, okay, it's first floor, second floor, third floor. They all become layers. That's what I really love about this thing. I also want to just put out a shout for, this is one of the most unbelievable steel models that we've ever gotten. And we think there's a gigantic opportunity for collaboration. But like, basically, we love good modelers, right? Good modelers make our job really easy. This model is dead accurate, and it allows me to do things like, you know, coordinate all of my SB, all my everything, my CLT. So if I look at my CLT, you know, that is like
if I
dead
saw
on
it
accurate.
right,
I'm not worried at all about this because I had a phenomenal partner that worked with us. And if I want to look at the steel against the MEP, I also had a phenomenal MEP contractor, and they were willing to put the time in to make sure we had the format we needed. And what we would do is they're like, well, you're the only one that has all the content. So we would clash detect between structure, steel, MEP, and we would hold meetings and we would show them this stuff. And then they would go back to their office and fix their stuff and send it back. And finally, we would end up with an absolutely cleared model. And of course, the architects is involved the whole time.
just looking at the drawing alone, Ilka and Steve, I noticed the cost savings because I can see when you show me the structure here of the steel, that it's already code connected, you know, whether it's an I-beam or a C-channel. And I know the fasteners, I know where it's going. I can almost tell you what size it is just from the 30 seconds I've seen you flash across the screen. That's insightful.
Yeah. So let me show you a little bit. I want to show you a little bit more. You mentioned fasteners. I'm going to show you the roof system on the CLT is pretty cool. I
Look at that.
don't necessarily need all the MEP. I'm going to just go with the roof right now. But what's really great about CLT and timber is for this kind of process. So this process works great with light frame panelization, but it also works really well. It's lagging. Hold on a sec.
This is like building an airplane. All the components are decided. They're all made here, there, and everywhere. Each part and piece comes in together, and we're flying high. This is the Star Wars of the construction industry.
So now I turned off the MEP, and now I can look at really, this is the, again, the blue is our glulam that are going to be sourced in the US, but everything else pretty much on here is an import, all pre-cut and a lot of pre-drilled from a company called HolzRaum in Austria. And what's really crazy is when you get into timber frame and CLT design, there are a lot of fasteners. And those fasteners are doing amazing things, but they also can create a lot of like expensive crane time and coordination time and things on site. So what's great is we need to model them. From the model of these things, we can generate details, but we also can send information to catch for ordering and sequencing and all that. So if I look at just the fasteners, these are the fasteners. I think we got down to 8,500 fasteners. Each fastener is a very specific application. And, you know, it, again, just like all the other parts in the model, it holds data that's really important to make sure things get in the right place. So, for instance, the manufacturer from the CLT company did not, they basically got our model, and all the CNC work from HolzRaum comes from this model as well. But they get, you know, an indication for the people ordering it, this is not going to be pre-drilled. So that means that factory knows it's not pre-drilled. It goes to zone R1. It says who's going to install it, who's going to provide it. And in this case, it's a loose part. So it's not going to be put into like an assembly. So anyway, there's just a lot of different things that you just, as soon as you have the part and you can attach data, you can just really kind of, you know, you can just really navigate the unknown a little bit. One last thing I'm just going to show you that I also really like is, again, bringing in content from our collaborators. This doesn't look like much, but this is CAD from the MEP engineer. They gave us the MEP model, but then they also gave us this old school CAD, right? Having this old school CAD locked into this and it's frozen in this model means that nobody can later come back and say, you know, why is that happening right here? Because it's in the model and this is where it goes. So it's like our model is really, what we're doing is we're just not saying it has to be some flashy 3D model. We're saying, how can we bring in content from collaborators that are used to working in different ways, but how can we still put it in the same place? Because I don't want to have to go to and open a 2D, you know, DXF file and then try to tell you that this is where it goes. How about you just take the DXF file, put it in the model, and then we all agree this is where it goes. And then if I turn on the MEP, it all aligns with CAD. So there's just sort of, I feel like we've barely scratched the surface on how to be flexible with our team, our design teammates and our builder teammates, and try to figure out what works for them, right? So then we can bring it into the SIMM model. And then at the end of the day, everybody's kind of like, it's like putting a bunch of languages together, you know? So I think
That's
it.
exactly how I see it, is you happen to have a fine example of all the different partners at play and the detail that they went into so that it could be made properly, it could be made once, they could ship it out with confidence, and then their example is set for other manufacturers to have their parts, pieces, and components done to this level. No one wants to make things more than once, so it's all there, single integrated manufacturing model.
Yep, I was going to show you one more thing because I just can't resist. So these are all the exterior wall panels that collective carpentry are doing. And so what's really great is you see this, you know, I can like decide what panels I want to look at, and I can just basically rifle through. So before we're ready to deliver shop drawings, we can just rifle through content, make sure that everything seems like it's included. In this case, it's got hold downs included, plywood. So anyway, there's just so many different ways, again, to navigate. You can just pick the attribute layer that you want to navigate along and just fly through the content. So I think that's mostly what I was going to show you.
It's all precision based. Gone are the days where you said it looks good from my house. And the fact that this is different languages is how you said it, really picked my ears. It's more than ideal to have these different languages pulled together. I'm so thankful to see it evolve and how this pulls forward. And I hope others are inspired by this and they're bringing the SIMM to the meeting, right? To have a Zoom call with Ilka and Steve. Who wouldn't want more of that?
Yeah.
Well,
And
thanks for letting us show you everything.
Yeah. And I think what we also realized, I think in the beginning, when we started this, we were on the quest of finding the one software that does it all, right? So because everyone is talking about efficiencies and avoiding redundancy and all of that. And I think what we realized is that it's not about just finding the one, you know, the one software that does it all, because there's just so many different applications and so many different things doing a whole project that you need. And for example, the CAD work is not really great at architectural documentation. So what we're finding is that it's, you know, the key is in translating one into the other and using what's there and making it one, you know, one language that can be spoken by everyone.
I think SIMM is a great culmination of the talents of each of you and David as well. When you have the different gifts, right, specialties that you each have, and then you integrate it as a manufacturer and someone who speaks to various manufacturers daily, this integration and this forethought of the shop drawings is to result in success in the field and replication upon replication. Thrilled, and I think we could come back for deeper dives on the process I mean, this one certainly is showcasing the panelized and the CLT and the pre-made structure for cold connection, but moving on more to the catch and those other programs, I would love to come back to the table and have a longer conversation with HolzRaum. And thank you so much, Steve and Oka.
Thank you so much.
Thank
Yeah,
you.
we were thrilled to come back. Thank you.
Yeah. Definitely.
So for our friends at Offsite Builder, you see the name in front. The Google machine will take you to HolzRaum Systems. You can learn more about SIMM, and we hope to see you in the next episode.
Thank you.
Thanks.